Hello everyone, and welcome to today's session of ZEISS Microminutes. My name is 𝗶হি𝗵𝗹𝘀, and I am an EM Applications Engineer based in the ZEISS Innovation Center, California, in the Bay Area, or in the building you can see behind me. For those who are joining us for the first time, I'd like to mention that if you have any questions or comments that you'd like to share during today's session, you can do so by posting the question in the YouTube chat on the right side of your window. Today, we're going to be talking about something that I find very exciting, which is customization within the SmartSEM environment. This is going to be spanning from the entire EM portfolio of conventional SEMs, or perhaps you're familiar with the name EVO, all the way to the 𝗶HI_SEMs, whether that's Sigmas or GeminiSEMs, and even to the 𝗶H_𝗳 world of the crossbeam. So I'd like to start by covering why customize your SmartSEM interface. Well, I think first and foremost, it's really easy to do. It doesn't require any sort of programming knowledge, if you don't know Python, that's not a problem, or Java. You're really just choosing options from a list to perform this customization. The list is pretty comprehensive, as we'll see. The second reason, I think, it's very attractive because it's included within SmartSEM. So, as I mentioned, whether you're dealing with a C-SEM, 𝗶H_𝗳, or crossbeam, well, it's going to be included in your SmartSEM, so it's something that is already built in. The third reason is it allows users to save time. So spending less time to search around for a certain menu or feature that's needed and avoiding that clicking around. When it comes to the new users, the novices, you're able to train your users much faster. So this is thinking about that sort of multi-user environment where perhaps a single person or a group of people are endowed with having to train new users. So imagine being able to train those users faster by utilizing guided wizards for the common workflows. This also allows making the workflows repeatable. So if there are workflows that are published utilizing customization and automation, well, now it's no longer dependent on which user is performing this operation. It's going to be somewhat standardized. It is also allowing users to control their systems remotely. So during the pandemic, it was a concerted effort by ZEISS to make the user interface operable from a remote setting. So there are settings and conditions where a user can operate these microscopes from a location that the microscope is not within itself. And lastly, leveraging automation, perhaps more on the expert side than the novice side, allows you to accomplish more and perform more audacious sort of workflows. So with the why established, I'd like to introduce those who aren't familiar with the multi-user environment of SmartSEM. So user accounts can be established by an administrative level account through the SmartSEM Administrator program. When making a new account, different access levels can be established and defined, and each of these different accounts can have different password protections so that novices would not be able to make changes to the admin account and vice versa. User accounts can be copied from either existing user accounts or from specific templates. So if one expert user wants to make a new account for a different expert user, well, they can just copy the settings and account from their own settings. If they were making an account for a novice, they can use a template for the novice account or make it from scratch. You can see in that image that there are different levels and permissions that can be toggled on and off, as well as other unique settings for each of those accounts. And that is what is signed into before performing any imaging sessions. Now, speaking about novice accounts specifically, what are the typical novice account settings? Well, there are a lot of restrictions and safety features that are put in place for a novice user, I think for obvious reasons. The first one I'd like to mention is safe navigation, which we're going to see in action in a second. So safe navigation is a built-in feature which will limit how high a user can drive the stage. This can limit the threat of collision from the sample perspective into the pole piece of the SEM, which is, I think, one of the more common concerns for multi-user facilities when providing access to really beginners. So this will actually take the capability away from those users to crash the pole piece, to crash the sample into the pole piece. This is set in the administrator by an admin level account and cannot be turned off. The second point is that they're unable to change a lot of the deeper level settings that perhaps an expert user might play with it in certain occasions. Certain gun parameters, being able to vent the chamber, turning off the field emission gun, and some of the other rarely used operating or maintenance conditions would not be accessible by these novice accounts. Third point is that these simple click macros for routine workflows, which we'll show in action in a second, for capturing first image or inserting a specific detector, exchanging samples, will be out in the open. They would be right in that toolbar with a nice visible button with helpful text for the user to click on and be able to navigate to without issue. Some of the other points, the menus can be hidden from the GUI. So as mentioned, those buttons that are tied to the common workflows would be planted towards the top of the view, and then some of the other peripheral menus that an expert user might want to toggle often would be secluded away so that it would simplify the workspace for those new users. And then, of course, the data zone, which is immensely powerful when you're doing your imaging for accessing and toggling specific settings on the fly, would have just the bare bones parameters that are necessary for operation in that data zone. And of course, later on, as the folks get more experience, this is maybe the first area for customization for those novice users, perhaps throwing in a logo for the lab or department of the company that's using the tool within the data zone, or adding some different parameters that are commonly used as well. So I'd like to show now how these simplified workflows can help a novice user. So this is, let me actually start this. So this is going to show how to perform the imaging. When you just load a sample, this person might have very little experience and training with the system. We want to make it as simple as possible. So with this user interface, this beginner is going to be able to acquire an image on their sample and then exchange the sample for a different one, all through the use of these simple click macros with very little user intervention. So we'll start that again. You can see as they go over this button at the top that says wizard, there's a helpful tool text that says this wizard will walk you through acquiring your first image safely, and then it starts populating these dialog boxes which a user will have to interact with. It explains what this macro is going to do. You can click no to exit, yes to proceed, and then it starts guiding that user through. So it says to change the acceleration voltage in the data zone. It recommends starting at 5 kV and then clicking yes to proceed. When they click yes, then it's going to run up the beam, open up any valves that need to be opened up. And once that beam has fully turned on, it's going to prompt the next step, which is going to instruct the user how to navigate to a specific region of interest. So you see that it populated the image navigation window as well as a new set of instructions to navigate to the region of interest. Double click on it in the image navigation window. So a user would just double click in that area. And of course, this image was taken with a nav cam, which is integrated to many of our microscopes. So once it's over that region of interest, clicking yes to proceed, it's going to toggle a specific detector and prompt an autofocus and autostig routine to run, just to get the user into a workspace that is close to good imaging conditions. As this continues, it's going to say that once the auto algorithms finish, ensure that you're in focus for the tallest part of the sample. And this is important for that safe navigation capability that is so important for limiting how high a user can go. So it asks the user to focus on the tallest part of the sample, which we are at this point. So clicking yes will establish the safe navigation for the set of samples that have been loaded. This is just some minor manual focus to get it really spot on after the auto algorithm was done. And then once this is clicked, as safe navigation is set up, a user is now fully free to capture images, move up in Z without concern of it interacting with any other part of the microscope. So that button at the top called grab is a shortcut to a powerful set of imaging conditions, particularly specific scan speed, utilizing pixel averaging, and once it acquires, it's going to freeze the image and then prompt the save dialog. So if we can count the total clicks up until this point, it's really been clicking yes on each of those boxes, and now just clicking grab to snap the image and save to save the image. And so now that that image has been saved, the user is now free to navigate to other portions of the sample or to move up in Z. So that's what we'll show now. That as a user drives up in the Z direction, you can see on the right side that the stage is moving up towards the pole piece. And as the user recording this, I just pushed up in full speed in the Z direction. And what actually is happening is as it moves up, it starts to ramp down the movement speed because it knows it's approaching a limit because safe navigation is on. I've set the spacing for safe navigation as an admin user to be about, I think it's 2 or 3 millimeters, which is really the closest I would go for my in-lens imaging. But if you'd prefer that to be farther, an admin can set that to be any value, 5 millimeters, 10 millimeters. That's totally customizable by an admin. But you can see that it totally stopped once we got to about 2 or 3 millimeters working distance, and a user cannot move up anymore. And performing the imaging now is very straightforward. Just focus and stig. Zooming in past 100,000x with the stability of the Gemini column is not a challenge, even for a novice. And then again, we just click grab, and then it snaps the image and prompts the save at that point. When it comes to exchanging the sample, there's a very nifty shortcut that exists on the control panel in front of the microscope. So a user just needs to click that exchange button, which you'll see after this save. And it will drop the stage, turn off the beam, close the isolation valves, and drive the stage back to the exchange position. So this whole novice interface that you see here is designed to make the workflows simple, straightforward, and safe for beginner users. You can see in the top left of the window it says novice, and that's because this is the account that's been signed in. In the next couple of videos, you'll see my name, Joe, with the more expert level settings that have been allowed. So yep, now we're in the exchange position just by clicking that button, and we're ready to go. The last video I'd like to show is a more advanced workflow, which involves inserting and retracting the ABSD. The interface is very similar to what you saw, where there's a prompt for a yes/no. What's nice about this button is it is all-encompassing, so we'll insert if it's not inserted and retract if it is inserted. So right now it's not inserted. It's going to automatically drop the stage. So everything at this point, again, is autonomous. After clicking the yes, it's dropping the stage. It's going to insert the detector. Once the detector is inserted, it's going to bring the stage back to where it was and then change our imaging conditions to typical backscatter electron imaging conditions. A little bit higher kV, higher current, of course selecting that detector and making sure that we can see the signal that it's capturing. As we've moved the stage, performing the autofocus and autostig is recommended, which is what's shown right now. And then once that settles, you'll see that we're at our working conditions, all just by clicking that yes button. And then let's say we capture images, we're satisfied, we just click that same button and it's going to perform the same steps in reverse and remove the detector now. Now, if you did not utilize this macro intrinsically, whenever you insert or retract the detector, it will drop the stage. But what this macro builds upon is bringing it back to that same position for imaging, as well as changing conditions when we're going from ABSD imaging, from our backscattered electron imaging to our secondary electron imaging. So here we are back at 5 kV and our secondary electron imaging on this cathode sample. It's doing that autofocus autostake and bringing us back to where we were. Okay. So you saw in all those videos the use of these macros and automation and shortcuts in the toolbar. The toolbar is something that is uniquely tied to different user accounts. So we saw already a little bit of the novice toolbar where there's a wizard for getting the first image and for saving the first image and exchanging. A question that often comes up is, what are some of the imaginative limits? What can an expert do with configuring a toolbar? So I took a snapshot of a toolbar that I use on our demo crossbeam laser. So again, what was shown in the videos was on a 𝗶իսem, but this level of customization exists across the portfolio of electron microscopy for conventional SEMs, the EVOs, the field emission SEM sigmas and GeminiSEMs, and our FIB-SEMs, the crossbeams. So you can see that how I set up my toolbar is quite organized, and any user has this capability, having an imaging section, having a stage section, a gas injection system section, a laser section, since this is a crossbeam with a femtosecond laser, and then an analytics section. I called out a couple of these just to kind of describe what each of them do, just to give a flavor for the level of customization that's possible. So under imaging, there's this one called Quad. Quad allows a user to simultaneously capture 4 full-sized images. It's often used in STEM mode, but it doesn't have to be. So what the macro will do is it'll launch quad mode. It'll allow a user to set the 4 channels independently, and then clicking yes will capture 4 full-sized images with 1 raster. The one under the stage section is called 180 rotate. So this rotates a lamella around for live imaging and milling. So typically when you're thinning a lamella and you're imaging with the SEM for endpointing, you got to thin both sides of the lamella. And if you wanted to see information on both sides, this button will shortcut the whole process of flipping the lamella around and bring you back to the milling orientation and conditions. So it's going to drop the stage by a few millimeters, tilt back to 0 from 54 degrees, do a compucentric rotation of 180, tilt back to 54, and then move back up 2 millimeters back to our milling conditions. So hopefully this is getting some creative juices flowing of what is possible for common workflows from an expert perspective to make lives easier and tasks easier. The last one I'll mention is under the gas injection system. When preparing a lamella for lift out, it's common to insert the gas injection nozzle and to disable a touch alarm, because when we come down to touch with the nano manipulator for lift out, in situ lift out, we don't want to set up the touch alarm. So this will, if the GIS is inserted, deactivate. If it's inserted, it will retract it. If it's not inserted, it will insert it and deactivate the stage touch alarm. So again, very, very useful when it comes to manual lamella lift outs for more challenging lamella processes. I'm going to take one level deeper of detail for those who are curious. When it comes to the automation, and many of the examples that I just mentioned, we're utilizing macros. As I mentioned on the first slide, macros do not demand any programming understanding or expertise. You don't have to know a language. The syntax is as simple as picking options from lists. The 3 main categories for making these macros are analog parameters, digital parameters, and commands. The difference between them is kind of simple. Analog parameters are parameters that have numeric values. Brightness, it has a numeric value of 53%. 10%, 14.256%. Your EHT, your acceleration voltage target, is going to have a numeric value. This is juxtaposed to a digital parameter where there are discrete states. It's either on, off, it's in, out, it's 1, 2, 3, 4, 5, but as discrete integers. Examples I mentioned are like having the crosshairs on, your beam is on, the backscatter detector is out. And then lastly, commands are any actions taken by the system that usually involve movement or a changing of states. So BSD being in, or changing the scanning from line averaging to pixel averaging, running autofocus, having scan speed 1 run, and so on. You can also call special functions, stage positions, other macros, and even leverage dialog boxes, as you saw, for prompting users to proceed or discontinue different workflows. I want to show a couple of examples, as simple as they can be, and some more complex examples. So when it comes to making the macro, you can have no decision structures, so just using analog parameters, digital parameters, and commands. What's shown here is one that I like to use. It's 3 lines. How I selected that is by going in the macro editor to where it says insert. I click that. It gives me those categories, command, digital, analog. When I click one of those, I get a list in alphabetical order. And then I'll just search under commands for scan speeds, pick 2. I then will go to the section for D, drift compensated frame integration, have that. And then because we have an analog parameter, I change my category to analog parameter, I select N, and then I tell it 225. All the syntax is populated for me, and that's a working macro. That can be run, and it will change my scan speed. It'll shift from whatever condition we're under to drift compensated frame integration, and the number of frames to 225, and I'll have a nice image. Stepping up a little bit in the direction of complexity, you can use decision structures. I've talked about this gas injection system macro on my expert account for Crossbeam. This is utilizing if-then statements. So if-then and do-while are kind of simple logic statements. So if a condition is true, then do this. If it's not true, then do that. The do-whiles are, well, while this condition is true, do this. When it stops being true, do something else. So this allows a user to specify if a detector is in, or if, in this case, the gas injection system is in, take it out. If it's not in, put it in, and so on. And then the last glimpse is perhaps, in a step further into complexity, which is where we can make a wizard that fully walks a novice user in the direction of capturing their first image, really holding their hand and making sure that they get to that point with a great amount of ease and clarity. Macro writing is something that we welcome users to try and experiment with. The entire EM Applications team is also available to support you with your questions, and we can share existing macros that we've made and we've found to be universally valuable for ourselves and for our customers. So don't be afraid to experiment, and let us know if you have questions or would like to utilize any of the macros that we have. Last thing I want to leave you with is that these microscopes and solutions are your ZEISS microscopes and solutions. So this is your opportunity to fully make it yours. You have the tools. Go play and have some fun. So I'd like to end off by showing a couple of useful links. We have some upcoming ZMCC workshops. If you follow this QR code, these are usually virtual, but some of them are in person, and these span the entire ZEISS microscopy portfolio: light microscopy, X-ray, and electron microscopy. We have in our ZEISS portal here, a user can make a free account and access an array of free training videos, again, across the entire portfolio. And then the last link is for upcoming live streams, so future micro-minute sessions just like this, which we host every Thursday at 1 p.m. Pacific time. And finally, you can subscribe to this YouTube channel by clicking this button, And I'd like to take this opportunity to thank you very much for joining us, and I hope you have a wonderful day.